Have you ever wondered what lurks in the deepest, darkest parts of our oceans? Join us as we explore the bizarre and fascinating world of deep-sea creatures, where the pressure is immense, the water is freezing, and the creatures are unlike anything you've ever seen. Beneath the calm, glistening surface of the ocean lies a vast and alien world that remains one of the least explored regions on Earth, the abyss. The journey begins with a breathtaking aerial shot of the sea, waves gently rolling under the golden light of the sun. As the camera plunges beneath the surface, colors begin to fade, and a haunting silence takes hold. Light diminishes rapidly, swallowed by the deepening blue until it gives way to total darkness. This descent marks the entrance to the deep sea, a world that begins around 200 meters below the surface and stretches downward into the abyssal zones, regions that can reach staggering depths of over 11,000 meters in places like the Mariana Trench. In this realm, the pressure is immense, over 1,000 times that of the surface, strong enough to crush human-made submarines not built for such extremes. Temperatures hover near freezing, and the absence of sunlight renders photosynthesis impossible, forcing life here to adapt in extraordinary ways. Despite the harshness, this pitch-black environment is far from lifeless. In fact, it's teeming with some of the most bizarre and fascinating creatures known to science, many of which have never been seen by human eyes. Bioluminescent organisms flicker like stars in the darkness, using light not only to lure prey but to communicate and evade predators. Gigantic jellyfish, anglerfish with glowing lures, and translucent squid with massive eyes have evolved to survive where few others can. The abyss is not just a physical space, it is a metaphor for the unknown. Over 80% of the world's oceans remain unexplored, and much of what exists in these great depths is still a mystery. Every dive into this shadowy expanse is a step into uncharted territory, where new species, strange geological formations, and hidden ecosystems await discovery. This extreme environment challenges our understanding of life itself, proving that even in the harshest conditions, nature finds a way. Welcome to the abyss, a dark, alien frontier beneath our very planet, where science, wonder, and mystery collide. These adaptations showcase the extraordinary ingenuity of evolution, proving that even in one of Earth's most extreme and hostile habitats, where pressure can reach over 1,000 times that of the surface, and food is scarce, life not only finds a way but also develops some of the most alien strategies for survival known to science. In this world of eternal night, light becomes a language, a weapon, and a lifeline. The deep sea reminds us that life is endlessly adaptable, and that darkness, far from being lifeless, is filled with flickers of astonishing brilliance. In the deepest reaches of our oceans lies a realm that defies everything we know about life on Earth, a world where creatures grow to monstrous sizes and take on forms so strange, they seem ripped from the pages of science fiction. This phenomenon, known as deep-sea gigantism, is one of the most captivating mysteries of marine biology. In stark contrast to the tiny and delicate creatures often found near the surface, many deep-sea animals grow to immense proportions. Scientists believe this may be due to several factors: the lack of natural predators, the slow metabolism caused by frigid temperatures, the increased oxygen levels at depth, and the need to travel long distances for food in a nutrient-scarce environment. In this world, being big is not just an advantage, it's often essential for survival. Among the most legendary giants of the deep is the giant squid, a creature that can grow up to 13 meters long, with massive eyes, the size of dinner plates, designed to detect the faintest light in the ocean's depths. Even more elusive is its relative, the colossal squid, believed to be even heavier and equipped with rotating hooks on its tentacles, an adaptation for gripping prey in complete darkness. Then there's the giant isopod, a deep-sea scavenger that resembles an enormous, armored pill bug. These creatures can grow over 2.5 feet in length and survive long stretches without food, sometimes going years between meals, thanks to their slow metabolism and energy-efficient lifestyle. But size isn't the only oddity of the deep. The abyss is also home to some of the strangest and most uniquely adapted animals on the planet. Take the blobfish for instance, a gelatinous, shapeless creature that lives at such high pressures its body is built without the need for strong bones or muscles. At the surface, it appears a droopy, formless mass, but in its natural environment, its soft structure is perfectly adapted to float above the seafloor without expending energy. In the crushing darkness of the deep sea, where sunlight disappears entirely just a few hundred meters below the surface, life faces challenges so extreme they border on the unimaginable. With no natural light to guide the way, the creatures that dwell here have evolved in astonishing and otherworldly ways to not just survive, but to thrive. One of the most fascinating and widespread adaptations is bioluminescence, the ability to generate light from within. In this environment, light is no longer a constant, it becomes a rare and valuable tool, used strategically for hunting, communication, camouflage, and defense. This phenomenon arises from a chemical reaction involving luciferin, a light-emitting molecule, and luciferase, an enzyme, allowing organisms to emit cold light in shades of blue or green, wavelengths that travel farthest in water. For many species, this self-made illumination is a matter of life or death. Take, for example, the anglerfish, one of the deep sea's most iconic and eerie residents. The females possess a bioluminescent lure, a glowing appendage that hangs like a fishing rod in front of their razor-toothed mouths. Motionless in the dark, the anglerfish waves its glowing bait to attract smaller fish, which swim directly into its jaws, mistaking it for a meal. Similarly, the viperfish uses rows of light-producing organs called photophores along its body to flash patterns that may attract prey or disorient predators. Some deep-sea squids can eject glowing ink clouds to distract threats, while other species produce red or ultraviolet bioluminescence, wavelengths invisible to most deep-sea life, giving them a secret, silent advantage. Bioluminescence isn't just for offense or defense, it's also used for communication and mating. In the deep's darkness, where mates may be scarce, synchronized flashes or specific light patterns can serve as signals to potential partners. Some species display distinct sequences of light to identify themselves or even to warn others of danger. Others, like certain jellyfish and comb jellies, produce cascading, rainbow-like pulses of light, either to lure prey or to startle would-be predators. In response to this ecosystem dominated by darkness and faint glows, the visual systems of deep-sea creatures have undergone radical evolutionary changes. Many possess enormous, highly sensitive eyes designed to pick up the faintest glimmers of bioluminescent light. The barrel-eye fish, for example, has upward-facing tubular eyes encased in a transparent head, allowing it to spot prey silhouetted against the dim light above. Other species, like some deep-sea crustaceans, have eyes adapted to see only the specific wavelengths emitted by bioluminescent organisms. In the deepest zones, where even bioluminescence is rare, some animals have lost their eyes entirely, evolving instead to depend on other heightened senses like touch, smell, and vibration detection. Far beneath the ocean's surface, beyond the reach of sunlight, exists one of Earth's most intricate and mysterious ecosystems, the deep sea. Unlike surface ecosystems that rely on sunlight and photosynthesis, the deep sea operates under entirely different rules, driven by chemosynthesis, detritus-based feeding, and slow, interconnected food webs. One of the most fascinating components of this world lies around hydrothermal vents, cracks in the seafloor that spew superheated, mineral-rich water into the ocean. These vents host vibrant oases of life, sustained not by sunlight, but by chemosynthetic bacteria that convert chemicals like hydrogen sulfide into energy. These bacteria form the base of a unique food chain, supporting entire communities of bizarre organisms such as giant tube worms, vent crabs, and blind shrimp, which thrive in temperatures and chemical conditions that would be deadly to most known life. Away from these isolated hotspots, much of the deep sea depends on a constant, slow drizzle of organic material from above, what scientists call marine snow. This snow consists of dead plankton, fecal matter, and decaying plant and animal remains that sink down from the more productive upper layers of the ocean. Though it may seem insignificant, marine snow is a vital food source for countless deep-sea organisms, from filter-feeding invertebrates to bottom-dwelling scavengers like the giant isopod and deep-sea amphipods. Occasionally, entire carcasses of whales or large fish will fall to the seafloor in events known as whale falls, creating temporary yet rich ecosystems that can sustain life for decades. Despite its remoteness, this fragile and finely balanced ecosystem is under growing threat. Pollution, including microplastics and chemical waste, finds its way even to the deepest ocean trenches, disrupting food webs and poisoning marine life. Climate change is also altering deep-sea temperatures and oxygen levels, threatening species that have adapted to stable conditions over millions of years. Perhaps most alarming is the looming threat of deep-sea mining, where corporations seek to extract valuable metals from the ocean floor, potentially destroying habitats that have existed undisturbed for eons. Because these ecosystems are so poorly understood and slow to recover, the damage could be irreversible. Preserving the deep sea is not just about saving alien-looking fish or exotic worms, it's about protecting one of the planet's largest and most important environments. This vast, hidden world plays a crucial role in carbon cycling, global nutrient distribution, and climate regulation. As our technology enables us to explore and exploit the deep ocean more easily, we must act with caution and responsibility. The deep sea is a treasure trove of biodiversity and biological wonder, and its preservation is vital not only for marine life, but for the health of our entire planet. The deep sea may seem distant and mysterious, but its health is deeply connected to the balance of life on Earth. As we uncover more about its wonders, we must also recognize our responsibility to protect it. From awe-inspiring creatures to vital ecosystems, this hidden world needs our attention and care. Every action we take, from reducing pollution to supporting sustainable practices, can help preserve these fragile environments for generations to come. Scientists are only beginning to understand the complexity of deep-sea life, and with your support, we can ensure these discoveries continue. Learn more, spread awareness, and support efforts to conserve the deep ocean, because protecting the unknown is just as important as preserving what we already understand.